Good morning, children. Today we will take the last topic of this lesson, that is language of chemistry, class 8th. Here today I want to tell you some important things about the limitations as well as what are the informations that we gather from the chemical reactions. So first thing is that in any chemical reaction there are few things we have to see or we observe, and that is the physical state. First point is the physical state. So the reaction we all know that the reactants as well as the products are used, and some reactants are used in the liquid form, some reactants are used in the gaseous form. So first, if we take the physical state, either the reactant or the product which are formed, either it is a liquid, solid or gas. Now, like here the equation I have written CO2 plus H2O, that is carbon dioxide, it is in the gaseous form, and water H2O, it is in the liquid form. So when CO2 combines with H2O, it gives H2CO3, that is carbonic acid. So when the gas, that is CO2, reacts with water liquid, it forms H2CO3, which is also a carbonic acid. It is also in the liquid form. So here what physical state we observe, that the product form, it is in the liquid state, either it is formed by the combination of the gas as well as the liquid. Another thing is that another equation, if we see Mg plus H2SO4, that is magnesium plus sulfuric acid gives MgSO4, that is magnesium sulfate and hydrogen gas. So what do we see here? Here we see that the hydrogen gas, that is H2O, it is evolved, and the evolution sign, it is represented by the upward arrow. In the same way, in the third equation, if you see AgNO3, that is silver nitrate, reacts with the sodium chloride, it forms sodium nitrate plus AgCl. So here the precipitation reaction we are saying that the silver chloride, which is formed in the form of the precipitate. So precipitate is always shown by the downward arrow. Here in the same way, another equation of precipitation reaction like AgNO3 plus NaI, that is sodium iodide. It forms NaNO3, sodium nitrate plus silver iodide. So silver iodide which is formed, it is in the form of precipitate. So what is actually precipitate? Precipitate is an insoluble solid which is formed in the chemical reaction. And sometimes in the chemical reaction, what do we see, that some acids which are used either in the concentrated form or in the dilute form. So concentrated acid means the amount of acid is large in the concentrated acid. कॉन्सेंट्रेटेड एसिड में जो होता है कि जो एसिड की क्वांटिटी होती है वो ज्यादा होती है, वाटर की क्वांटिटी लेस होती है, उसको हम कॉन्सेंट्रेटेड एसिड बोलते हैं. और जो डाइल्यूट एसिड होता है, डाइल्यूट एसिड मीन द कॉन्सेंट्रेशन ऑफ वाटर इज मोर एंड द कॉन्सेंट्रेशन ऑफ एसिड इज लेस, सो दैट इज कॉल्ड डाइल्यूट एसिड. Like here we can take the example zinc plus 2HCl, that is hydrochloric acid. When they combine together, they form zinc chloride, that is ZnCl2 plus H2O. Here also the gas is evolved, that is hydrogen gas. So it can be shown by the upward arrow. So here the acid which is formed, it is HCl, it is in the form of dilute acid. They are reacting with the zinc, it forms zinc chloride plus hydrogen gas. Now what information we gathered, that in some chemical reactions we use the catalyst. So what is catalyst? Catalyst is actually the things or the substance or the chemical we can say which alters the speed of the reaction without itself undergoing any change. मतलब जो कोई भी रिएक्शन की स्पीड को ऑल्टर करता है, ऑल्टर करना है यानी चेंज करता है, या तो उसको बढ़ाता है या तो उसको घटाता है. तो जो बढ़ाता है मतलब which helps to increase the speed of reaction, that is called positive catalyst, and those reaction which helps to decrease the speed of reaction, they are called negative catalyst. So some catalysts are positive which increase the speed of reaction, and some catalysts are negative catalysts which decrease the speed of reaction. So in some cases, in some chemical reactions, the catalyst is also very important, that is N2 plus 3H2. Here in the presence of catalyst only, it forms the ammonia, that is 2NH3, and this is called the Haber process. So ammonia is formed by the Haber process, and here the catalyst is used to alter the speed of the reaction. Now in another equation we can see the reversibility, that is the reaction is reversible, means it can be reversed, like 3NH2 plus N2 gives 2NH3, and when 2NH3 is given in the form of catalyst, in the presence of catalyst, they can again be reversed into hydrogen and nitrogen. So this process, that is 3H2 plus N2, it is formed 2NH3, and again 2NH3 can be reversed into, or it can be converted into 3H2 and N2. So this process is called reversible process, or we can say the reversibility type of reactions can also be seen in the chemical reaction. Now here light, another important thing is the light. We all know that light is very important, especially in the process of photosynthesis. Photo means light and synthesis means making food. So whenever we all know that plants only make food in the presence of sunlight and chlorophyll. So when carbon dioxide react with water, that is 6 CO2, 6 molecule of CO2 react with 6 molecule of water, that is H2O, it forms C6H12O6, that is glucose. Glucose is formed here, and as a result of photosynthesis, oxygen is liberated in the atmosphere. So this reaction is called photosynthesis, and some reactions also take place in the presence of light. Not only this, but it is the example of the reactions which takes place in the presence of photosynthesis. Now another important thing that we gather from the chemical equation is the heat and temperature. Means in some chemical reaction the heat is evolved, and in some chemical reaction the heat is absorbed. So in those type of chemical reaction where the heat is absorbed, it is called endothermic reaction, and those chemical reactions where the heat is evolved is called exothermic reaction. So here we can see the example of endothermic reaction like CaCO3, calcium carbonate, when it is given means when heat is absorbed in the calcium carbonate, it forms calcium oxide and carbon dioxide. So this equation, that is calcium carbonate, gives CaO plus CO2, calcium oxide plus carbon dioxide. So it is an endothermic reaction because here the heat is absorbed. And second example is the example of exothermic reaction. Exothermic reaction where the heat is evolved. So here we can take the example of CO2 plus 4H2. Means carbon dioxide when combined with hydrogen, it forms methane and water. So here the heat is evolved. So this type of reaction where the heat is evolved, this type of reaction is called exothermic reaction. So in some chemical reaction we can see the heat is evolved, and in some chemical reaction we can see the heat is absorbed. And the next point we gather in the chemical equation, in some chemical reaction the reactions takes place in the presence of electric current, like decomposition of water. If we want to break the water into hydrogen and oxygen, because the water is made up of actually hydrogen and oxygen. So when we want to break the composition of water, that is hydrogen and oxygen, so what happens? We have to apply electricity. So after applying the electricity, what will happen? That this water H2O will break into hydrogen, that is 2H2 plus O2, that is oxygen. So this type of reaction takes place in the presence of electric current. So electricity is also very important in some chemical reaction we can see. And the last thing we see in the chemical equation is that some chemical reaction the pressure is applied. Like CO2 combined with water, that is H2O. When both the CO2 and water, it is reacting at high pressure. High pressure I have written here. Then what does it form? It forms H2CO3, that is carbonic acid. So carbonic acid is formed only when carbon dioxide react with the water at high pressure. So these are some of the informations we gathered from the chemical reactions. And after this chapter is completed, and you will have to complete all the question answers as well as whatever the exercise question given in the book. Thank you.